Assalamu alaikum. Hello. Let's continue with vector addition. Okay, so as you can see, I've drawn a diagram, right? And it's a diagram of a triangle, but the difference here is that instead of lengths, the sides are given by vectors. So this is essentially what's called a vector diagram, and you will see this pretty often in your O levels and even your A levels. Perhaps not as simple as this, but you will definitely see vector diagrams. So you have, in this question, you have OA and you have OB. What you have to do is find AB, right? So how do you do that? Well, one could say that, okay, this diagram kind of looks pretty similar to the one that we had in the last video, which basically said that, okay, you had OA, OB, you had one vector and another, and when you add them, you kind of move this second vector over here, translate it like this, right? And then follow this vector, then follow this vector, and you'll get a resultant that begins from over here and ends over here. If you follow this vector and add this vector, follow this vector and add this vector to this vector, right? You get the position vector of this point, which is this, right? So notice here that, okay, so when you add two vectors, no matter how they're graphically represented, it could be like this, it could be like this, or it could be even like this, right? When you add them, you have to translate them in such a way that, that the tail of the second vector coincides with the head of the first vector, right? And when you draw it like this, the resultant is given by drawing a line from the tail of the first vector to the head of the second vector, and that is known as the head to tail rule. And it doesn't work for just two vectors, it can work for multiple vectors as well. For example, if you have like vectors like these, and let's draw a peach one, and you just have to translate it like this. Okay, we choose our first vector to be here, and then our peach vector to be kind of like this, going from here to here, head to tail, and then we draw a resultant from the tail of the first vector to the head of the last one, right? Because that's what you get, right? When you add this vector, and this vector, you get the position vector of this point, right? And the position vector of this point is just given from the origin to this point. So that's how you represent them both graphically and algebraically, right? So considering this diagram, OA and OB, if you were to add OA and OB together to find AB, what you would end up getting is, if you were to translate it like this, right, you would end up getting a resultant vector along the lines of this, right? And as you can see, this is nowhere close to AB. It doesn't resemble AB at all, and even if we're not doing things to scale, you can see that this is wrong, because AB is facing kind of diagonally downwards. It has a positive x component towards the right, but a negative y component. And if you add O and OB, the resultant that you get would have a positive x component and a positive y component. So that's not gonna work, right? That is definitely not gonna work. So let me just erase this, and we'll kind of try and find another way to find AB. Okay, so now let's get back to the head to tail rule. If you can notice over here, the head to tail rule applies. OA, the head of OA, is kind of meeting or coinciding with the tail of AB, of the vector AB. So now if we want to draw a resultant, we have to draw it from O to the head of AB. But that's just OB, right? Which is already drawn. So we can easily see that OA plus AB is equal to OB, right? So, and if you want to go through it logically, if you travel along OA, then travel along AB, you end up at point B, right? And if you add OA and AB, what you get is the position vector of B, right? Because you end up at the point B, and the position vector of B is OB. So you get essentially this. So if you kind of manipulate the algebra, AB equals OB minus OA. And AB can be given by 5, 2 minus 2, 3, which is just 3 and minus 1. This is much more comprehensible than OA plus OB, which would have been 7, 5. Both of these components are in the positive, are positive, but AB has a negative y component, and this makes much more sense. And this is the way to do it, because we kind of move through it logically. Go to follow OA and then AB, and you end up at B, which is the coordinates of B, the position vector of B. And the position vector of B is just given by OB. And you move the things around, you get AB, right? So this is your answer. This is how you do it. In questions like these, you often have to see, often have to check, where the head to tail rule applies, and then check where the head of one vector meets the tail of another, and kind of draw resultants from there, right? And that's basically how you do these questions without having to memorize like formulae, that you have to do this when you have this, and you have to do this when you have this. All the subtraction and addition kind of equations come from this basic rule, head to tail, no matter how many vectors there are. In the next video, we'll probably end up doing a more complicated example of vector diagrams, inshallah. But for now, that's it. Thank you very much for tuning in. Please like, share, and subscribe to my channel. And if you have any feedback, please leave it in the comments below. I would love to hear back from you guys. Thank you very much. Allah Hafiz.